video, I think I am not able to run it, but this basically shows that over several iterations how the whole thing improves. So for the sake of time, probably I'll skip this, no worry about that. So it was showing you that how gradually over time it improves, and then all these works they got published in reputed journals. So in this work what I could show that as compared to the high fidelity, suppose the polymerization model, if it is used with an uh, optimizer, then it used to take 15 days of time, whereas we could propose this ANN based optimization, okay, or machine learning based optimization, which could make it 10 times faster. Okay, so basically my message is that ANN is extremely strong in capturing non-linearity involved in an function. So just to show you, I just took probably this Ackley function taken from literature to show you how complicated or non-linear it is. It has several local optima, okay, and then only one probably global optima here. But then our aim was through surrogate optimization to mimic this function. So basically to tell you that can machine learning build such a function. So you see on your right, you see this is the ANN built surrogate, okay, which would be very difficult for you to find the difference between the original function. So that's the power of machine learning. And so machine learning can build such a nice replica of the original function. Then if you use this replicated function in an optimizer, you're going to find the solution, right? So in this way, there are several other applications also. So first was about the steady state data. The second optimization is, what about if your data set is time series in nature? Okay, so it took a industrial grinding circuit. So I'm not really going into details of this circuit, but you can see there are one ore feed as an input, there is one water. So that this water is another input, this water is another input. Okay, so altogether three. This water is not changed industrially, so we are not considering that. And this is the product stream. There are 6 parameters here which we can consider as an output. So this is a 3 input 6 output system, but the difference of this system from the previous one, here it is a time series data. So it's a differential equation which is solved. In the previous one, though it was differential equation, but we were solving it under steady state, so it was a steady state data. So this particular thing is going to show you how can we use ML versus optimization, that is the proposed method, for a time series kind of data. So similarly, we have an industrial validated model. We used 2000 data points which were generated for system identification of this particular application. So out of those 2000 points, first 70% were used for training, whereas the last 30% were used for validation. So like artificial neural network, there are special forms of artificial neural network which are known as the recurrent neural network, which are used for modeling such time series data. So under RNN, there are methods like GRUs, gated recurrent unit, or probably long short-term memory network, LSTMs. So used all such kind of models to basically model a dynamical system. So these are some of the ways of giving the disturbance to the system, because if you give disturbance to the system, this is going to generate the time series data which is varying in nature. So this is known as PRVS kind of signaling. We use PRVS to generate the training data, and then we used RGS, another way of generating the input output, so that people should not think like, okay, you generated only this way your training data and you are going to generate the same way your testing data, then probably there is a high chance it's going to match. Okay, but then we use 2 different kind of mechanisms to generate your data, just to check how powerful machine learning is to match the behavior. And then we build our model, and we can see that probably these are the training matches. Okay, so your solid curves are original data, whereas your dotted lines are LSTM prediction. So we use this transform kind of mechanism which I presented in our earlier presentation. Okay, and that is used. So everything is chosen by that optimizer. So there is least amount of human intervention. That is the most important part I'm talking about. That probably whether it's a novice user or an expert user, it really doesn't matter. Your algorithm is going to decide how your machine learning model should be. So everything is automated. Okay, and then you can see this is the extent of matching which we got against those RGS signals. So these are also all published in reputed journal. So through this second case study, I wanted to tell that the transform mechanism which we proposed, that is valid for steady state data, that is valid for this dynamic data. And the third case, which I am not going into details, here we wanted to show that probably through machine learning, you can show that your algorithm can learn how to draw. Okay, so some of the images we used for training. Okay, and we used something called convolutional autoencoder, which is presented here. Okay, and we used the transform mechanism to design this optimal CAE, convolutional autoencoder. So what we are presenting as a differentiator with many other machine learning designers, because they choose many things, specifically the hyperparameters of machine learning in manual manner. Whereas our transform proposes that you just give it to me. You give me the data set, and or probably you give me your model, or you give me the access to your experimental setup. Our algorithm is going to decide what would be the experimental plan, under what situation the experiments have to be conducted, that is the experimental plan, number of experiments, and what would be the typical architecture of this complicated ML model, because otherwise it's going to create a lot of difference when a novice is going to design it, or probably when an expert is going to design it. So in that way you can see these are the original images given to the machine, and these are the machine generated images. You see hardly there is any difference, because now machine has learned how to draw these images. So here also the conclusion remains the same, where you are going to show that our transform can probably design most of this ML based task on its own. So this transform has been applied on several applications. I'm not going to details, just to excite you that probably what ML can really do it for us. There are several processes which all are industrial in nature. So we have several collaborators. We provide a lot thanks to you for providing either data or probably providing us fund to do the project along with them. So this is a very brief summary that we have used this proposal across several such proposals. And this is a very brief slide what our group has been doing. So again, going through, there are several such applications across energy, starting from wind farm, then how to go for efficient combustion, hydrogen production, bioenergy supply chain, battery management system. So you can probably go through this slide and see that we are trying our best to spread our tentacles across various processes, just with a great motto to check probably the efficiency of machine learning and optimization, and how probably this new combination can probably improve the efficiency of such processes. So on the right hand side, different aspects of ML we are working on. Okay, and these are our collaborators with the help of. So again, in just 2-3 minutes, I'll wrap up. This is something about a problem which we have been working for the last 10 years, that probably a green field is given to us. How can we place the wind turbines optimally in that green field to maximize the energy harnessed from that green field? So this is having several aspects which we are taking care of through these various machine learning techniques. Okay, this is another bio supply chain problem which we have targeted again, and this is another problem of battery management system. This is probably how to make our combustion more efficient. This is like so there is something called lignin, which is a source of several industrial chemicals. So how can we probably optimally perform our experiments so that with minimum number of experiments we can find our job done? Okay, these are several projects which are going on in our lab. Okay, again, just to excite you that there is extreme opportunity of application of ML and optimization in several fields. Okay, you can just go through some of them, so you can understand that means probably many things can be done together. These are some of our publications over our effort out of machine learning and optimization, and these are the whole workforce. All thanks to them, whatever work our group could do. Okay, so that's what I tried presenting briefly before you. Okay, and then thank you so much for your patience hearing, and hope probably the success message of machine learning and optimization could reach you, and then we would be glad to answer any questions you have.
It was a really insightful session, Professor Mitra. You beautifully highlighted the intersection of optimization techniques and machine learning and sustainability, and also the way you explained surrogate optimization with the study of polymerization process was really engaging. I now invite Professor Sudeshna Ghosh to present the vote of thanks to Professor Mitra.
Good morning, Professor. Can you hear me?
Yes.
Yeah, thank you so much. First of all, I would like to appreciate your you have given consent for your presentation. I know you're a very busy person. You have to go right away to some another work, but still, I will like to on records thank you. So I would like to sincerely thank Professor Mitra for accepting our invitation despite his extremely busy schedule. It is truly an honor for all of us to have the opportunity to listen to you, sir. And one thing which was not told by you in your CV, but I know you have been awarded Best Teachers Award many times. Now, from your presentation, it was very clear why you have been awarded that. You know? Yeah. So, okay. So, what I understood from your talk is that you tried to explore different possibilities efficiently, especially when the experimental methods are time consuming. Am I correct, sir?
Yes, yes.
Yeah, so idea of using surrogate models to reduce computational effort while still maintaining accuracy. Actually, it was very useful and interesting for all of us. And on a personal note, I will also like to share that I learned a lot from you, especially about how to do research in a structured and ethical way, and which is missing nowadays, the ethical part. So thank you so much, sir, for giving insight to that in my career. And
Sorry to interrupt you. We are learning from each other at every opportunity.
Anyway, thank you so much, sir. I know you have to rush for another meeting. Once again, thank you from the department side and my side. Thank you so much, sir. I appreciate.
Thank you so much. Hope probably the presentation was useful.
Yeah. So, yeah. Okay.
Professor Mitra, I'm Professor Seema R. Pathak, and thank you so much for having this session here, and our students got immense benefit from your session. We are running from pillar to post. We have 5 sessions running parallelly right now.
Correct. So,
yes. Yeah. So thank you so much. And I see that the students have immense satisfaction on their face. So maybe they are understanding very well. So thank you very much, and request you to be collaborated with us. Thank you.
Sure. Thank you so much. Thank you so much for the opportunity, and all the best and good luck for the conference as well as all the students. Thank you. Have a great day. Yeah. Bye.
Thank you.
Bye.
So I see that today's students are attending it very enthusiastically at every place. So please continue.
Thank you, sir.
So, Dr. Ayushi, can I leave?
Yes, sir. Yes, sir. You can leave.
Yeah. All the best. Good luck. Yeah.
Thank you, sir.
Bye.
Okay, now I would like to introduce our esteemed session chair, who is also our next speaker. Dr. Brij Mohan. Dr. Brij Mohan is an assistant professor at Hansraj College, University of Delhi, with over a decade of teaching and research experience in mathematics and computational sciences. He completed his PhD in mathematics from the University of Delhi, with research focused on nonlinear evolution equations, Soliton theory, and analytical methods in applied mathematics. Also, he has an MTech degree in computer applications from IIT Delhi. His work spans interdisciplinary domains including symbolic computation, machine learning, and mathematical modeling, with applications in physics, fluid dynamics, and emerging computational sciences. Dr. Mohan has published more than 20 research papers in reputed international journals and has received top cited paper award 2025 by IOP Science in both mathematical and computational science and physics. He is actively involved in academic service as a reviewer for leading journals and has delivered numerous invited talks and workshops in different universities in India and abroad, including UAE, Vietnam, and Saudi Arabia on Soliton theory, neural networks, Python, LaTeX, and AI tools in education and research. In addition to his research contributions, he has led funded projects and supervised student research internships. Dr. Mohan's current interests include artificial intelligence, data analytics, and their applications in modern scientific and financial systems, making him a strong advocate for interdisciplinary learning and innovation. Other than academics, he actively participates in social works and runs a free competition coaching for students of marginalized communities under AMS Trust in Ghaziabad. And in the last 3 years, more than 80 students have been selected in different government jobs. I now request Dr. Brij Mohan to take over the session and also begin with his lecture. Thank you, sir.
Like that, or I have to come here. Okay. pointers वगैरह दिया ओके कोई मैं कर दूँ ओके कोई कोई ओके न्यूरल नेटवर्क की बात चल रही थी मैं वहीं से स्टार्ट करूंगा बट आई विल गो टू द एडवांस ठीक है तो फोर थिंग्स राइट हियर आई विल क्लियर द फंडामेंटल देन आई विल डू द माय वर्क एंड देन आई विल एक्सटेंड द एडवांस वर्क ठीक है तो जब भी हम बात करते हैं human neural network you see such kind of picture that means that the neurons are there and they are directly connected right but when you do the mathematical machine learning neural network you can find out like this right you have already understood some keywords here first layer is coming inside that is called as input layer when you come to the output which will be called as output layer and whatever it is in the middle that is hidden from you so that's why we call it as hidden yes hidden right so we can define any functionality here for getting dependent on the input it that is a function that we can register again first to में आपने लिखा हो input x f is a box और output y ये देखा ना सेम चीज है ये वही है बस दिखाने का तरीका हमने बदल दिया there is some kind of x now take x as a vector so how will it be x1 x2 x3 x4 x1 you got it it's like a calculus one that's right this is a y y1 y2 y3 yn so this is a y and we put in the data as a vector right and whatever it is there that is so very simply we can understand that that is nothing but in mathematics only it's look like in a machine learning some kind of patterns how we can connect the mathematics to it और इस terminology का क्या है जो कीवर्ड्स हम यूज कर रहे हैं क्या कीवर्ड्स तो मैथमेटिक्स को क्या बोलेगा ओके मैथमेटिक्स में सिंपलीफिकेशन के लिए है राइट इट्स ओके So let me come back to the topic. So let's understand the first mathematics that then we will understand the question. Okay, in mathematics we have this ax plus by equals something right? See, that's not about mind things, right? We have two y. उसके साथ हम कुछ coefficient a and b, right? So ax plus by is our the whole input one side left side and outside out. So in the graphics, our mind will think, okay, x is coming with the multiplication of a, y is coming with the multiplication of b, and we will add it, it will become the c. Is that clear? Yes. Fundamental, very easy to do. We have done it in the sixth class, right? Now come to the machine learning. How we see the change here? We just change the terminology and the keywords. So whatever variables name was there, now we convert it to whatever coefficients we call it here, here. So if you connect that thing, how mathematics is becoming the machine learning, then we can easily understand any pattern, right? Now see, a is here coefficient. Now here I have changed a as weight, and the what is the weight value? So the notation how will we do it? Last graphic with America, ऐसे था चीज़ W1 W1 2 something there. So that is कहाँ से आ रहा है तो कहाँ पहुँच है? From where is coming? From first neuron. So that's why the notation is 1. Where is going? To the output here that is Z. So the notation will be way from 1 to 3. Can you tell me the second one? 2 to 3. W 2 3. If I add another one here, what will get? That is so that's how we can understand how we convert the mathematics to machine learning. So it is the same how our mind is working and how the machine learning computation working work. Both are same. Let's have one little advanced example. Like yeah, very easy equation, mathematical equation. Sin x plus by plus cos x plus by is equal to c. That's your something is performed and output is there. So I will put here output layer. What are the input layers? Then tell me how many independent variables are there? How many? and 4 by 4. Okay. So इसको एक नाम दे देते हैं, क्या नाम दे देते हैं? So x by a को नाम क्या करते हैं? Wait, the value is a. This get value is b. So that is 1 1 2 1. Okay. Because mathematics is not mathematics is a actually nothing else. Mathematics is very complicated arts, then it became science, and now maths of engineering living. So that's how mathematics changed. So लेकिन हम रूप से पढ़े, तो रूप से यही है. That is nothing, just symbolization. कुछ नहीं. Next, what we will do? J1 will go to sine. Here J1 will go to cos. So what does that mean? दो functions हम बना रहे हैं. उसका क्या नाम दे दिए? J2 sine. तो J1 ठीक है? J2 बना. J1 ठीक है? That's how. और ये दोनों का जब समीकरण करेंगे तो how will we define the way? From where it's coming? J2. Where is going? See, J3. How many of you can have that understanding? How many? Now you can understand the thing, right? Very simple. Correct? आगे बढ़ो. So that's how we design, and इसको हम क्या बोलते हैं फिर? Neural network model. ये term होता है कि 1 2 3 1 2 1 like that. So it's nothing but जिस पे लेयर में जितनी quantity है वो numbering यहाँ पर. So how many? 2 1 2. So that's why the network model will be 2 1 2 1. इससे मैं समझ जाऊंगा कि मेरा मॉडल है inside है. So starting head 2 से output है 1 से and the reason is 1. Is that correct? So that terminology I will use develop my methodology shifting from mathematics to the theory. So I have defined one method that is called SPT. The solid base है उसकी study का that one method. Symbolic biology techniques. Completely mathematics है. So I am converting that mathematics to the machine learning concept so that I can change it and I can find out the new things and the fast. Because computation will do fast, right? Okay. So next, so we have objective here that understanding the data system, how we will do and how we will use the neural network model. That is our first objective. Another is how to find the hidden layer functions and we can use them to construct our functionality. Right? I will use here symbolic binary technique. So I will not go so deep in the mathematics now because you are more just connected here. You want to learn something so that you can have some interest in it. Right? And in future you can maybe do some work in this field. Right? So I will go to that and you will find out the solution for it. Okay. So how many of you know PDs or Ds? Easy, right? Partial differential equation. What is it? So my work is basically depend on nonlinear partial differential. Nonlinear means where you have the coefficients with the dependent variable, right? कोई भी ऐसी टर्म है जिसमें आपका dependent variable coefficient है उसको nonlinear है, right? So that is nonlinear term. That is a very important term because as के बार आते हैं तो partial differential करने ट्रांजिशन में and that's why it's more. So that is if you go dispersing means right? Like you can understand that. Okay, so that is terms are another linear term depending on the partial derivative with respect to the different independent variables. So what I am doing here in the starting in that term methodology SPT, I will convert this nonlinear partial differential equation to one this form, and this form is nothing again just a symbolization of the functionality. So when to convert this one equation to this four equation also is not easy. So what we did, we defined new algorithm. So that is published in this work. So we designed an over and efficient method for obtaining Hilbert binary method. So we can use that algorithm here, and directly you can come from 1 to 3. Also, you have to buy and ask. If you get format to understand all and every step, but if you want to do the coding, then you can go to this my work here and then understand it. You can convert it. So I'm not going how we are converting this now, but you can understand how what we are doing actually. This partial differential equation is something with the and independent variable, right? Derivatives are there. क्या कर रहे हैं यहाँ पे? जो हमारे पास डिपेंडेंट है उसको कन्वर्ट करने किसी और फंक्शन में. So that's the करके हम किसी फंक्शन को चेंज करके दूसरे उसको बोल देते हैं ऑक्सिलरी, राइट? ये तब हमेशा यूज करेंगे. चाहे फिजिक्स में मैथ्स में ऑक्सिलरी वर्ड है, जहाँ भी है समझ जाओ कि something is happening and something is they are changing to that, right? So we are changing this u to this function. Now here we can see इन सब में से g निकल के कहाँ पर आ गया? So that's why it becomes linear, but it's not linear because degree is 2. So that's why we call it as pi. Pi is 2. Pi linear. So that is the change that we have to see. इसके लिए कोई नहीं है. तो different method for example ली सिमेट्री. अगर आप अलजेब्रा में अच्छे हैं तो आप ली सिमेट्री, आप अगर कंप्यूटेशन में बहुत अच्छे हैं, कोडिंग बहुत अच्छे हैं तो आप हिरोटा मेथड यूज कर सकते हैं. अगर आप आपका वेव ट्रांसफॉर्मेशन बहुत अच्छा हाथ है तो आप वेव ट्रांसफॉर्मेशन मेथड यूज कर सकते हैं. So that's how we handle the non-linear fields. मेरा फिर चूंकि मेरा मैथ्स भी था और आई डिड एवरी से सर मेरे मैथ कर दिया बैठ भी रहे मेरे यहाँ के टाइम पे. So I'm always sharing this with you. So that's an honor. जब कभी आप उनसे मिलते हैं अभी आई थिंक लास्ट में कॉलेज में गए सर को अपने कॉलेज भी बुलाया था. तो ऑनर. तो वहां से क्योंकि मैथ्स और कंप्यूटर से मेरे दोनों बैकग्राउंड रहे हैं तो आई वाज गुड इनफ टू हैंडल दीस टू थिंग्स. So that's why I'm not switched to and I became the new direction of the research. So इंडिया में जो मैं काम करता हूँ most probably I'm the only one. इसलिए जो कि मेरे एरिया में रिसर्च नहीं था, that's why I did all my course public. तो अभी वर्ल्ड वाइड लोग उस पर काम करें, I will discuss it with that. आउटपुट हमारी क्या है आने वाले टाइम पे. ओके, ये क्लियर है. सिंपल फॉर्म में हमने लेकर आया नॉन-लिनियर पीडी is converted to the linear equation, but it's not linear, it's a bilinear. That's what the name is bilinear. Okay. So ये एफबीटी का फॉर्मुलेशन है कि हम सॉल्यूशन डायरेक्ट फाइंड आउट कर सकते हैं by designing this function. Okay, I will not go beyond that. Something expression is there, easy expression. Something is summation there, something is coefficient, something is exponential. That a to the power b. ऐसे आप समझ के चलिए माइनर में easy रखने के, right? Because I don't want to make it tough for you. Easily. और उसका summation expression है कोई a1 a to the power b1 plus a to the power b2. इस expression में you can understand that easily. So इस expression में now you will start to find out that the first solution. पहला solution g है maximum. तो हमारा g है function तो था तो वहाँ पर हमने g को क्या माना देखो. जब हम सिर्फ n is equal to 1 plus expression में 1 ले रहे हैं that is the first solution. So ये expression है. Mathematics में ये expression. In my method I will put b0 plus b1 e to the power 7. ठीक है, इससे हमने सोल्व किया हुआ है, सॉल्यूशन ऑलरेडी हमने निकाला. Now what I will do, I will convert this expression to the machine learning. So how will you do? Now remember that वेट को किसका कन्वर्ट करेंगे कोएफिशिएंट्स को वेट से प्लस. क्लियर. और जो फंक्शंस हैं e to the power sin cos डायरेक्ट डायरेक्ट क्या आता है डायरेक्ट how we converted it. I will follow my rule and I will convert it here. Can you see d0 is now try to f समझ गए. That is output आएगा. b1 is way and we will our exponential function है तो function है तो वहां पर जाए 2 जाए 3 या लेकर 2 लेकर 3 जो आप अंडरलाइन you can simplify that. That correct? So now you can say mathematics में देखो तो expressions are very easy. But जैसे मैं न्यूरल नेटवर्क में कन्वर्ट कर रहा हूँ, how many coefficients are there now? 96, right? It increase. So but how we can handle that? So computation power हमको चाहिए. Then we can utilize any software, mathematics का मैथमेट और Python. हमें इस Python वहाँ पे हमारे पास inbuilt package का यूज कर सकते हैं. inbuilt package हमारे से तो डायरेक्ट आप वहाँ पे उतनी मेहनत की जरूरत नहीं पड़े. Being a mathematician. So that's how we change this and जो function है यहाँ पे हमारा now we got that quadrant. K0 plus V1 to the power alpha. It is divided into two waves and the functionality और दो functions के input क्या है? जैसे यहाँ पे याद करिए sin kx plus b में kx plus b है था तो hidden layer बनी. Sin किसमें था? Hidden layer. That's why exponential function are there. उनको हमने convert कर लिया है hidden. तो मैं ऐसा लगा और ऐसा से इंडिकेशन आउटपुट क्या है? हेलो फंक्शनैलिटी है अपना hidden layer. तेरे को बताना है I think that's my mistake. I can say it's not. इधर तो ठीक है. मिररिंग पे वो टच होने के बाद एकदम चला गया.
हेलो हाँ सर कॉन्फ्रेंस रूम में यहाँ पे स्क्रीन चली गई थी हाँ अभी
I try something on something, it fails. And it fails. And it fails. Then I build up a new research paper, and that is how it will get done. Like you can't do it. How come is that? Yeah. There is not always research की ये होगा ही. अगर आप वो भी नहीं कर रहे हैं, तो अगर आप proof ये कर दें कि ये नहीं कर सकते हैं, so that is another kind of. So that's how we build up, right? Okay. So यहाँ पर जाइटो में जो फंक्शन है यहाँ पर हम फंक्शन ले लेंगे and then we put it here with the submitted. Okay. कितना टाइम है मेरे पास अब बता दीजिए. I will change my screen. ठीक है. आपको पीछे मैंने लिखा है, गौर से देखो क्या न्यूरल नेटवर्क सेम है? Yes, here. क्या जैसे G1 वे जाइटो में जाइटो से आ रहा है, जाइटो हमारा जाइटो से आ रहा है. Now you can understand X, Y, Z, and T are independent variables. Where is the sum A? Here is one diagonal. They follow the combination. Diagonal is the other function. पहला function क्या है? B के पास one. तो ये constant function है यहाँ पे. इसका नाम हम क्या लिखेंगे? Yes, इधर. यहाँ पर क्या था दूसरा function? A की power diagonal. Remember? तो वो function हमारे यहाँ पर है. So that will become your hidden layer. So that will become your output. So easily कैसे हमने convert किया? Since that D0 plus D1 diagram को machine learning में और machine learning से neural net. तीनों से मैंने आपको clear कर दिया. I hope you know it now, right? अब आप समझ पाएंगे at least जब आप कभी networking में neural networking तो आप easily समझ जाएंगे कि ये notation क्या होगा. 3-1 D1 से आ रहा है और anyone just big anyone D1 से आ रहा है and second पे जा रहा है जो second neuron है that is layer 2 and 2. That's how I change. Although you can change here if you want to put J1, J2 or J1 or J3. So you are free to choose your symbolization. कोई फिक्स नहीं. आप जैसे आप symbolization करना चाहें you can fix that and you can research on that. ठीक है. तो ये हमने अप्लाई किया उस फंक्शनैलिटी को इसमें रखेंगे जो हमारे linear equation है binary equation उसमें पुट कर दीजिए स्टोर कर दीजिए for a solution. And so that's how we do. So we find this solution. So here हमारे पास एक पहला solution आ गया है U1 और किसमें है ये weights में और इन weights का वैल्यू हमको पता है सबका किसका A था किसका B था और we can define arbitrary choices also. So we can find out the different graph. See इस तरह का ग्राफ साथ में क्वेश्चन पे देखा होगा जब लोग सर्च करते हैं बोर्ड के साथ में किस तरह पैटर्न पे करते हैं. अगर आपने देखा सर्चिंग करके यही पैटर्न होता है. इसका नाम है किंग. तो किंग सॉल्यूशन बोलते हैं जबकि हमारी आई एक स्टेट वाटर की एक स्टेट ऊपर से बाहर निकल कर ढल गया, उसका सेकंड स्टेट में ट्रांजिशन हो। तो व्हेनेवर एक स्टेट से सेकंड स्टेट में ट्रांजिशन हो, तीन सॉल्यूशन से इसी वाले केस पे वो सर्व करते हैं। यहाँ पर ये ऐसे बढ़ेगी आगे को धकेलेगी जो भी सर्व कर रहा है अंदर, और वो अपने स्टेट को से मूव कर, क्योंकि जो फोर्स है वो हमेशा इक्वल रहने वाला है। रीजन क्या बोला था मैंने स्टार्टिंग में, समीकरण कभी भी खत्म नहीं होता जब तक वो डिस्ट्रॉय करोगे आप उसको अलग एलिमेंट्स। सो दैट्स व्हाट वी डू। सो वी कैन build up our ocean gas water is here, but in the PAS Hirota Vanilla method given by Hirota, तो उसमें एक प्रॉब्लम है जो मुझे दिखा दिया था को बाउंड था, यानी वो ऑलरेडी प्रोसेस में डिजाइन नहीं, तो जो नहीं था दैट्स व्हाई आई डिजाइन न्यू एसपीटी। तो एसपीटी जो मैंने डिजाइन किया वो जनरलाइजेशन वर्जन है जो था, तो उस मैथड की वजह से नाउ आई कैन फाइंड आउट दी सॉल्यूशन आल्सो। ये पॉसिबल नहीं था सॉल्यूशन द रीजन आर्किटेक्चर से आ गया मेरे पास डिफरेंट वेज से आर्किटेक्चर केस मेरे पास है। विरोधा पे वहां पे कांस्टेंट था 1 1, सो तो इसमें देखिए आप वेट इज 1 1, सो दैट इज विरोधा मेथड। तो मैंने विरोधा मेथड का भी सॉल्यूशन दिखा दिया, तो मेरा सॉल्यूशन ठीक है, और नए सॉल्यूशन भी हम स्टडी कर सकते हैं। यहाँ पर एक इस तरह का सॉल्यूशन है, जब भी वेव्स अपर साइड में जाएगी दैट इज कॉल्ड एज द ब्राइट, ये ऊपर है और डार्क इज, तो दैट्स हाउ वी डिजाइन द नेम इज डार्क एंड ब्राइट सॉल्यूशन। नाम भी बता दिया, ठीक है। तो अनदर वन इज ये सिंपल सॉल्यूशन है कि अपर साइड में जा रहा है लाइक दिस मूविंग, ठीक है। और इनके कुछ ग्राफिक्स से हम देख सकते हैं कि टाइम के अकॉर्डिंग किधर मूव कर रहा है, 0 रेड और 2 रेड, ये 2 रेड टाइम को करेगा, तो किधर मूव कर रहा है नेक्स्ट डायरेक्शन में, पॉजिटिव डायरेक्शन में। दैट्स हाउ वी गेट द रिजल्ट्स एनालिसिस, है ना। सबसे टफ काम होता है तक में आराम से देना अपना, आप सॉल्यूशन तो निकाल सकते हैं लेकिन उसे एनालिसिस करना। सो वहां से हम इन चीजों को सीख के एंड वी कैन डिजाइन वन सॉल्यूशन। सिमिलरली नाउ वी विल गो टू द सेकंड वन, कैरी सिमुलेशन नंबर 9, मैथमेटिकल वेरी इजी, कितना है, कितने कोएफिशिएंट दिख रहे हैं सर, 1 2 3 4 और फंक्शंस 1 2 3, इजी। मशीन लर्निंग में दे दिया सेम पैटर्न को, कितने वेट चाहिए मुझे, मेरे को 3 से 6 हो गए, 3 से 6 के नोटेशन है उसकी वजह से लिखे इक्वेशन 1 2 3 स्टार्ट कर रहे हैं, तो लास्ट में करना होगा 3 4 5 6 बने, दैट्स व्हाई से आ गया है 1 से नहीं गया 3 से 6 तो 4 ही है, ठीक है। दैट्स हाउ वी डिजाइन रेट, द फंक्शंस आर इनसाइड इधर लेयर डन। तो कितने कोएफिशिएंट हमारे पास, द मल्टीपल कोएफिशिएंट्स वी हैव, so we can understood it the different choice आर्किटेक्चर हमारे पास है, पर अलग सा डेट पॉइंट हम डिफरेंट कैसे फाइंड आउट कर सकते हैं, हाउ वी कैन डिजाइन दैट, ठीक है। टाइप्स को वही करेंगे, फंक्शन को बाइनरी इक्वेशन में रखा और सॉल्व, ठीक है। अब आप कोई भी सॉफ्टवेयर यूज करते हैं सॉल्व वगैरह आप यूज कर सकते हैं, ठीक है, बट ये वैसा वाला सॉल्व नहीं होगा, आपको थोड़ा सा काम करना पड़ता है, कोएफिशिएंट्स निकालेंगे, ट्रिक सिस्टम ऑफ अनडिटरमिनेट और सिस्टम ऑफ इसको सॉल्व कर दीजिए, कोई नहीं वो भी हो जाता है अगर जब आप रिसर्च करेंगे, सो इट विल बी इजी। नाउ अंडरस्टैंड दिस, सी मैथमेटिक्स, मशीन लर्निंग, न्यूरल नेटवर्क, मैं आपको तीनों तरह से दिखा देता हूं ताकि आपको इंटरेस्ट ना हो, इसलिए आई एक्सप्लेन में आया था आप सी नेटवर्क कैन अंडरस्टैंड इट इजीली, वेरी इजी, राइट। नेक्स्ट सॉल्व किया फंक्शन है एंड देन we can understand the graphics. Can you see that here? How many solution are there? एक यहाँ पर है हल्का सा, राइट, फर्स्ट सेकंड टाइम फर्स्ट कंडीशन सेकंड टाइम, तो दो सॉल्यूशन है इसका, तो ये हम क्या कहते हैं दो सॉल्यूशन, ठीक है। तो सिमिलरली ये हमारा हेरोटा मेथड से आएगा और ये हम अदर स्टडी कर सकते हैं। अब सी यहाँ पर ग्राफिक्स देखिए तो इस तरह का था, लेकिन यहाँ पर तो ग्राफिक्स बोला गया तो ये सॉल्यूशन तो किसी को नहीं पता था, ये हिडन है, ऐसा एक्सप्लोर। तो अब ये कौन सा सॉल्यूशन है, बार-बार रिपीट होती है जब चीजें, क्या बोलते हैं उसको, पीरियोडिक, यानी कि हम पीरियोडिक फंक्शन की स्टडी आइडेंटिटी कोएफिशिएंट होने की वजह से कर सकते हैं। तो रिजल्ट भी आपने देखे होंगे क्वेश्चंस में, देखो पहले आपके बकेट है, अंदर मान लीजिए कि आपके पास रिजल्ट का सब बनेगी, राइट, सर्कुलेशन में मूव करते हैं बकेट के अंदर, सो यू कैन स्टडी वाटर वॉशरूम, कितने तरह की वेव बन रही है। आप अगर वैसा पत्थर डालेंगे तो अगर आपको 90 डिग्री पे डालेंगे पत्थर अंदर जाएगा और वाटर आप आएगा, होता है ना एकदम से और वापस ही जाएगा। इसका नाम है लंप। लंप में भी उसकी प्रॉपर्टी क्या है, यहाँ पर आपने पत्थर डाला ना सेम 90 डिग्री पे आप उठेगा वाटर, उसके बाद में सेम आप पे जाएगा। इसका मतलब क्या हुआ, लोकलाइजिंग नेचर, बाहर मूव नहीं कर रहा है वाटर, जिस जगह पे आपने वाटर है वहीं कहीं टिके होगा। तो जब भी इस प्रॉपर्टी में आप देखें दैट इज कॉल्ड एज द लोकलाइज्ड नेचर ऑफ द स्टेज। तो वो लंप हो गए। पत्थर मार के तो देख सकते हैं पत्थर में मूव करेगी बाहर, सॉरी लॉन्ग हो गया राइट, और अलग स्टेट में मूव कर रही है बट ऐसे आपका केबल। सो दैट्स हाउ वी स्टडी। ठीक है, तो ऐसे ही आप इजीली समझ सकते हैं, थोड़ी ग्राफिक समझ सकते हैं किधर को हम मूव कर रहे हैं। क्लियर है? लास्ट थर्ड थ्री सॉरी फंक्शन कैसे लगाओ मैथमेटिक्स में फंक्शन दे रहे हैं। हां राइट, नीचे देखिए मशीन लर्निंग में क्या हो गया, इसका मतलब जैसे जैसे आप अपना बढ़ने वाले हैं एंड वन पे अपर टर्म टू थ्री सॉरी दैट्स हाउ योर मॉडल विल बिकम। ठीक है, लेकिन अगर आप रिसर्च में कर रहे हैं तो हम लोग क्रिटिकल दिखा और हमारे सॉल्यूशन 1 2 3 पर सेटिस्फाई कर रहे हैं और जिसकी पहली प्रॉपर्टी तो 70 में 80 में पड़ी गई और हमको डाटा से आप 1056 का प्रूव कर रहे हैं। तो मैं समझता हूं कि जो मेरी रिसर्च आज की वो करेक्ट है क्योंकि हम उसका फर्स्ट सॉल्यूशन भी दिखाकर चल रहे हैं कि आया हुआ है। गॉट इट? प्रूव कैसे करोगे, आपका जो चीजें हैं आप रिसर्च करो सही जो ऑलरेडी मार्केट में है ऑलरेडी एनालाइज है वहां से आप कंपैरिजन करके बताते हो ये हमारा आया हुआ है तो ये डिफरेंट है हम कैसे कर सकते हैं। सो दैट्स हाउ वी स्टडी। यस, do we have one? It's so like a tough now very easy understanding your mind. Done. Graphics. Solutions निकालेंगे and we go to the graphics one. कितने सॉल्यूशन दिख रहे हैं? ये ऑलरेडी निकाले हुए हैं लोटा मेथड से तो ऑलरेडी एग्जिस्टेड है, अनदर एग्जिस्टेड नहीं है। तो दैट्स व्हाई रिसर्च गो है ना, जब तक आप कुछ नया ऐड करेंगे तो रिसर्च कोई नहीं, लेकिन रिसर्च तभी बनता है जब आपने पहले वाले यूज करेंगे। तो दैट्स हाउ वी डिड दिस। सो एट द लास्ट तो रिमार्क्स है इन कामों को आपके ध्यान प्रोसीड करते हैं। सो वी हैव गिव हाउ मच in inward orientation now फिर होगा दिस फॉर्म डिफरेंट है। तो इस फॉर्म का मीनिंग क्या है कि जो डेटा है रैंडमली चूज कर लो है, वो किसी भी एक्सपेरिमेंट से नहीं आया। व्हाट इज इंडिपेंडेंट वेरिएबल थे x y z एंड p, तो मैं रैंडमली डेटा बना लेता हूं 1 3 4 5 रख के देखा कुछ आ गया 5 3 4 6 रख के देखा कुछ आ गया। ये व्हाट इज 100 डेटा निकाल लीजिए। डेटा का जो मैनेजमेंट का कैसे करते हैं हम लोग की कौन सी बता रहे हैं थ्री साइड में इसमें आपने देखा होगा एक था y आउटपुट तो क्या है ऐसा था और एक था नॉर्मल y। कैन यू डिस्क्राइब दीस टू? नहीं ये क्या समझाया जाता है वेरी बड़ी चीज है। 100 डेटा पॉइंट में रैंडम निकाल दिया, रैंडम में से हम क्या करते हैं 80% डेटा को लेते हैं टेस्टिंग के, सो लर्निंग, और जो 20% है वो छोड़कर रख देते हैं टेस्टिंग। तो 80 डेटा है अपने मॉडल पे लगा के देखा क्या उड़ा रही है बॉडी और मेरा एक फंक्शन आगे लेता एक मेथड मेरे पास बनकर आगे मैं लर्निंग सिखाता कि ये बार-बार इस तरह के एनालिसिस को बनाती है। मैथमेटिक्स हम करते हैं न्यूमेरिकल ऑप्टिमाइजेशन गूगल एनालिसिस में यूज करते हैं ना, इंटरपोलेशन यूज करते हैं राइट, करते हैं ना, वहां से आप फंक्शन मिल जाते हैं ना। पैसे समझिए कि डेटा गया 80% डेटा यू आर यूजिंग टू लर्न द मॉडल, वहां से फंक्शन आ गया उस फंक्शन पे टेस्टिंग कौन सा करेंगे 20% जो डेटा मैंने अपने पास बैकअप रखा हुआ। तो अगर मेरे 20% डेटा का जो मैच है उस 80 टू 90 के बीच में मैच हो रहा है, इसका मतलब है कि हमारी फंक्शनैलिटी है वो वैलिड। और अगर 70 से नीचे तो भी खराब है और 90 के ऊपर भी है तो भी खराब है। ये मैं सोचिएगा 100% आ गया तो सही है, नहीं मशीन लर्निंग में ऐसा नहीं होता। अगर आपका मॉडल 100% दे रहा है ट्रू, आपको खुशी होगी किस्म से कि नहीं डेटा है, नहीं रॉन्ग माना जाता है, ये आपका मॉडल बायस है। 100% तो वो दे नहीं सकता ना मॉडल। तो आप क्या करते हैं कि 100 भी आ रहा है तो फिर उसको चेंज करके कुछ और पैटर्न यूज करेंगे, अपना मॉडल का आउटपुट है 90 से 95 के बीच में लेकर आएंगे, तब आपको एक्सेप्टेंस मिलेगी कि हाँ आपका मॉडल वास्तव में 100% है। नोबडी विल बिलीव समथिंग बायस इज देयर और यू हैव डन समथिंग रॉन्ग। लाइक दैट. सो वी कैन अंडरस्टैंड. उसके बाद क्या हो सकता है, जो हमारे वेट है अगर उसमें हम प्रोबेबिलिटी लगा रहे हैं, कोई जो डिपेंडेंट वेरिएबल है एक्सटेंस है, फॉर एग्जांपल जो मूव है, हम बैठे हैं, थ्री डायमेंशन तो हमारे पास है, टेन डायमेंशन अगर डायमेंशन एयर हो सकता है, डेंसिटी हो सकती है, एयर प्रेशर हो सकता है. तो मेरे मॉडल में क्या एक्सप्रेशन है, कितनी प्रोबेबिलिटी उसकी होगी, ये व्हाट दैट पॉइंट. अगर मैं चाहूं अपने मॉडल में प्रोबेबिलिटी ऐड कर सकता हूं वेट के साथ, तो जैसे प्रोबेबिलिटी ऐड की स्टैटिस्टिकल मॉडल स्टार्ट हो जाएंगे बनने, और उसी को समझने के बाद में हम जा सकते हैं पाइथन न्यूरल नेटवर्क. दैट्स हाउ वी कैन कनेक्ट मैथमेटिक्स, मशीन लर्निंग, मॉडलिंग, न्यूरल नेटवर्क, देन पिन पे जा सकते हैं बिना. दैट्स हाउ वी कैन कनेक्ट. ठीक है, आई एम वर्किंग नाउ हियर. ठीक है, और पिन के लिए हम यूज करते हैं पाइथन में है pxd पैकेज है pxd का. अगर आप कभी लैब में करना चाहें कितने का, तो वहां से टैग सेटअप करिए और अपने ऑर्डर को वहां पे डायरेक्ट आ सकते हैं. आपको बहुत अच्छी रिसर्च है, आपको हेल्प भी कम करेगी. अगर आप आने वाले बिजनेस हो तो आई विल सजेस्ट थिंग्स आप कर सकते हैं, और इससे पहले ये वाला सब कर सकते हैं. राइट, ओके. चूंकि ये वाले काउंटेड इंडिया में तो ताकि बराबर मामला था, तो दैट्स व्हाई आई डिड लास्ट ईयर. पर मैंने अपना कोर्स सारे को भी कर दिया, अरे पेपर भी है, पेज सब कहीं जाएंगे आपको इजीली, ताकि जो में लोग हैं वो काम कर रहा है इस फील्ड में, राइट, काउंट नहीं रहता है. सो जब से मैंने इसको ओपन किया है, नाउ यू कैन सी ये गूगल का मेरे वेबसाइट का एनालिसिस. आप वेबसाइट पे जाइए, वहां पर आपको सारे कोड सारे रिसर्च मिल जाएंगे. ठीक है, सो कंट्री वाइज देखें कर रहा हूं इधर से, जैसे कि कुछ कंट्री काम कर रही है, डाउनलोड कर रहे हैं मेरे वैल्यू को, राइट. इंडिया में तो काफी अच्छा दिख रहा है, तो इसका मतलब मैं आई एम हैप्पी कि मैंने जिसके ओपन किया है उसका इम्पैक्ट है, राइट. मेरे हिसाब से मेरे तक सीखना रहता है, तो वो चल रहा है. खाली देशों में कुछ आउटपुट है, कुछ यहाँ पे यूरोप कंट्रीज में और नॉट साउथ अमेरिका में, राइट. तो हमारा रिसर्च है वो कंट्री वाइज जा रहा है. अब आउटपुट कैसे पता चलेगा कि ये काम कर रहे हैं, जब उनके पेपर को समझ, राइट. ये मेरे पेपर नहीं है, ये वर्ल्ड वाइड लोगों के पेपर में हमारे काम पे करो. ऑल आर Q1 Q2 कैटेगरी, और ये बड़ी वर्कर्स हैं हमारे लिए. तो ये सब मैंने बाहर ही रखे हैं. अब तो आई थिंक हो गया अभी तक तो काम पर दूसरों की मुझे से काम कर रहा था, पीएचडी करना है, पीएचडी तो कर ही है, दो लाइन 3 साल के लिए 4 साल, लेकिन उसका इम्पैक्ट क्या है, इम्पैक्ट करने तो किसे लोग आपके काम तभी प्रॉफिट है ना. तो दैट्स हाउ आई स्टार्टेड माय पीएचडी. तो मैं पीएचडी में एडमिशन लेने से पहले सोच लिया था, क्योंकि मेरा नाम जब तक रिसर्च में नहीं आएगा दूसरा पेपर में, तब तक मजा नहीं आएगा. क्योंकि हम दूसरों पे काम करते हैं, न्यूरल पे काम कर रहे हैं, पे काम कर रहे हैं, है ना, इसके नाम पे जारी के नाम पे, but I will see ourselves someone has done something work and they are utilized for methodology and they are studying it, then we feel something good, better, right. So ये कुछ आउटपुट्स हैं जो हमारे रिसर्च से हैं. ठीक है, कुछ रेफरेंसेस हैं, और ये सब कुछ ये हमारे ग्रुप में लर्निंग एनालिसिस एंड नॉलेज साइंस इधर यूजफुल डॉक्यूमेंट्स हैं, प्रोग्रामर कॉल्स हैं, डिपार्टमेंट्स हैं, खासा मतलब सब हम साथ में काम करते हैं, ताकि हम आपस में एक दूसरे से शेयर कर पाएं अपनी रिसर्च और उनको सब समझ पाएं. ठीक है, तो और कुछ रिसर्चर्स हैं जो साथ में हैं, कुछ इंटर्न्स हैं साथ में. ठीक है, हर साल में इंटर्नशिप निकलता है, वहां पे भी हम ट्राई करते हैं. आई होप yes, anything any doubt please come forward. Not doubt, then you can review. You can review the doubts so that you can improvise, right? Exactly. If not, then
ठीक है सर को वोट ऑफ थैंक्स तो कर दूंगा. So I sincerely thank Dr. Brijmohan on behalf of the organizing committee for your insightful and enriching lecture. Your presentation beautifully illustrated the powerful synergy between nonlinear and evolution equations and neural networks, and the depth of analysis and clarity with which you have explained complex ideas have truly made this session intellectually stimulating. And I think each and every one of us have understood it properly. Thank you so much, sir. For we are very grateful for the time and effort that you have taken to share your valuable knowledge and your research with us. Thank you, sir.
So, my talk, we have next our speaker, as I said, my mentor also, Professor Rajesh. So, I will brief something about him. So, Professor Sharma is a Saxon chair professor and former head of the Department of IT Learning. Earlier, he has served as a faculty of mathematics at the IIT Kanpur. He had earned his PhD mathematics from IIT Delhi, and his main research focused on algebra and cryptography. So, my research was not cryptography, but in the past it was data. So, Professor, I have worked as a postdoctoral fellow in France and Germany for 3 years. He has been teaching PhD for more than 36 years and has gained 44 PhDs. Currently, who are working with him and more than 80 campus projects and one of them is here. So he has published more than 400 research articles in related education journals. Professor Sharma has participated in several conferences, including the International Congress of Mathematics, that's called ICM, in 1994, and in Zurich, Switzerland. So presently, several friends are working with him on sponsored projects also. So he has traveled widely and never ever talk at several national and international universities. So with the great round of applause, I invite Professor Sharma to be here to discuss his talk on crypto sustainable path present. Professor. लैपटॉप बताइए ये अपना लैपटॉप बताइए
बोलो
ये वाला लगा तो सर
उसमें फिर वो कराना
It's a great honor and pleasure to be here at this but given that his name is definitely go there. I've been here several times, and every time I find people, there's always a joy. That's really pleasurable. One thing in life I have always desired is to remain young. As you know, it's very difficult to stay young for a long time. So what I do, the next best possible thing is to be among the young people. And that is why I always try my best to be among the young people. And for as much as time is possible. And for this reason, I keep on moving place to place. University is good. College is college. School is. In fact, kindergarten is such a I think a total time actually implements that. You talk to a person who has just started knowing the words, you will enjoy that. And for this reason, that I'm here at the place of the same course. For this, I'm extremely thankful to you, University, the BT side, you know, for some time. You also I did any other slide to it. And of course, we have so coming here is only thankful to Sam or this and to be all who have given opportunity to spend some time with. Now coming to your sustainability, so this is very important that something we inherit and then it stays with us for a long time. It's only a wish, only a desire. But fulfilling this spiritual desire really is very not as it is. As things keep on changing at fast rate and keep pace with the changing scenario. It's almost impossible, but still we try. Particularly those subjects which change almost from the daily basis rather minute to minute. One of them, of course, the Olympic switch that nobody knows about. Always know everything about X. And that is the whole thing. The basic principle of spirituality is that nothing is safe, nothing is secure. And how that we cope with. You know it's safe, nothing is safe, secure. It's still you have to sell yourself when you start it. You know, nothing is safe, nothing is secure. So I take you a little bit time machine that how things work and how things have gradually changed to where do we stand today? Where do we expect to be tomorrow? Is there any hope that we shall be able to achieve that? Or is just a wishful thinking? So we take you that someone will switch off the lights when I say and switch on when I say. I'll show you something. So see how things started. The communication in the mother and child. It's the most earliest communication that comes into the life. In fact, it begins before birth and it continues even when you are not there. Same as with mathematics, it begins before birth. Oh, my son or daughter, please be expected this time or in the future. So the math starts there. And he is no more on this date and this hour, then what will happen? Then us what we do. So same in this math is always with us, there for the not. So the same way. So the child is about to breathe into the free air, but the mother and child start communicating for it. Then you understand fantastically. It doesn't require any language. But to know it well, that we begin at that stage. And soon after the birth, how we to start. So what that is the voice. Moment I can go and sometimes when I mean over there. But what after that? starts then, you want to teach child. And that starts with a change. So what this girl starts saying, and particularly when the firstborn, child is even more, she doesn't know that only whatever is taught or read and all those things. But third, it fails immediately when you enter into the lab. That's what. That's the approach. So then how do you start teaching this child? Then you say 7, child you. Then say 1. Well, never says 1. You tried it. And what do you do? Then you say, so push dinner. Start the chocolate with your hand. You get that. Stop it. 1. That's it. That. So 1 say, what is learning? So what learning chocolate? Then repeat again. 1. 1. And after 4 to 10, he says 1. Now both are active. Both are active. Mother is happy because she taught him 1. The child is happy because he got 1. 1 chocolate. The next day she comes with 2 chocolates and then she says 2. He says 1. Because he knows if he says 1, he'll get a chocolate. No. 2. And third attempt was successful. He says 2. Both are happy. You're happy. You got him 2. He's happy. He got chocolates. 2 chocolates. 3, 4, 5, 6, 7, 8, 9, 10. And he says immediately 10. So it is so simple. And look at the pocket. And then you find 1 chocolate costs 50. So by the time you have taught him 1, कितने का खर्चा हो गया? मैं कहता हूँ कितने का खर्चा हो? 200. 200. No problem. Yeah. 200. 200. 200. How we learn actually. If someone starts saying something around the whole family says 200, 200. Yes, great. The first day you get only 1 chocolate. The next day you get 2. The first day is 22. The next day is 4. Together you are taught 6. But you have taught only 2. You spend 2. The first day, second day 40, third day 60. By the time you taught in 3, you have already spent 100. How much do you expect? It's still 200 rupees? And how much? How much? The first day you gave him 1 chocolate. Second day you gave him 2 chocolates. And then you gave 3 chocolates. And then 8, 9, 10. How many chocolates? How many? 55. One costs 20. So money spent is how much is 1,100. 1,100 you have spent only to teach. It's a very costly affair. You teach a child, it is very, very costly. ये तो बहुत अच्छी है इसको उल्टी सिखा ले और arrive at this also तो उल्टी सिखा लेता है तो next day she comes with removing 1 and then 9 the child starts crying Doesn't 389 places will that people 48 will 10 for this. Now empty. 9, 8, 7, 6, 5, 4, 3, 2, 1, and then she said, where? Those empty one. Zero. No child will ever say zero. They कुछ नहीं zero zero करते रहते हैं. But by that time to come again, man, how much spend? I will get to that. How much altogether let's spend? Going back? I want to push through. वापस ना टोटल कितना हो 200 300 9 and के बाद तो 9 8 7 5 अब कितना कितना भी कम हो गया now 1100 so you need to say again 11 so 2200 जल्दी हाँ बच्चे नहीं पढ़ा तो भी कितना say something there are only two things no, no, that's all. Wonderful. That is my job. How much? 200. 2000. 2200. Again, 200. 2 on him. 9, 8, 7, 5. What? So how much? What?
20 rupees.
How much money you spent altogether in this whole exercise? 2000. 2000? So when you go back, then you say 2,200. So reverse process, and you again spend another this one 1,100, and therefore altogether is 2,200. Is that so? But you have not given him 10 twice. You have not given him 10 chocolates twice. Only once. So this is not. So this time this is not. You did not give 10 chocolates twice. So it should be minus 200. Therefore, this is 2000. बच्चे को 1 से 10 तक पढ़ाया और फिर 10 से 1 पे वापस पहुंचाया 2,000 रुपए इसलिए I but no one ever thought that after this when you say zero I never say zero what is the importance of zero actually it was not understood for a long time to be essentially nearly in the development of the number system first was the counting numbers or the natural number, and if people nearly to denote the zero, and we take measure in the Hampton, and you tried also, they were born in India, somewhat 500 years ago, before Christ. So it took a long time. And this is also interesting that when you say that these many chocolates, all the games are for the young people. There's no game which is for the old age, except playing cards, which I do not count. And so, but there is one game which is the most uneven game is being played. Always in a game there are two sides. Both have a single objective. What is this one? Is to win. And how is it to be achieved? By defeating the other. And everything is fair, blood. See, in every game is a part. But have you ever heard of a game in which on one side there is only one good and on the other side everyone else, the whole class, and this game being played daily in the morning, it took hours, is still both like anything. That is why they meet again and again at 9, 8, and so on. Then a teacher comes with the sole objective, आज के दिन आराम से कटे, and every student comes with the only objective. आराम से छोड़ो, दो चुपी न ले, आराम से रहे. That is what is the objective. That is the spirit of every day. So one teacher comes and he says, add up to 100. Before the teacher tried to sit down, one child said, sir, 50-50. What is this 50-50? How do you get it? Yeah, click go 1, 2, 3. This. And right once again. 1, 2, 3. And then again. 50. This is and this is right. And 101, 101, 101, 101. How many rows are there? 100 rows are there. So 100 into 101. You have done the job twice. Divide this whole thing by 2. And that is your 50 into 101. And so it's 50. You know this child, who this child was? Carl Frederick Doss. Carl was a German child. His name was Carl Frederick Doss. And he was a prodigy child. He did so much in mathematics, physics, and mechanical engineering, and so on and so forth. He is known as the Prince of Science. Wonderfully educated. This huge literature after Doss, ऐसे भी है ना ऐसे लिखते हैं ना तो ये ऐसे हो जाता है. This is pretty common in Germany. So there is huge literature about that. हाँ तो बच्चे का आ रहे थे उसके बाद क्या होता है? So after you have taught him this at your level, spending from 2000 rupees to profit mistake to respect को सिखाया. अब क्या करें इसका? बैठता भी नहीं और बैठने नहीं देता. Then other times, should there be some place, should there be somebody who can take care of notorious child and take this boy or girl? चलो आज बात करते हैं कुछ टाइम ये बात करेंगे रेस्ट करेंगे और लेके कहाँ जाती है? To some place and then enters and then hands over the hand of this child altogether strange acts This strange hands are of the teacher. This strange place is school. And then she runs away like anything like that. पीछे पीछे ना आ जाए एक तीन की तरफ बाहर आती। उसके बाद मदर इज आफ्टर ऑल मदर और बाहर से तो निकलती है लेकिन जाती है फिर घूम फिर के किसी ना किसी खिड़की से आके देखने की कोशिश करते हैं तो नहीं रहा Just look at him out there. Other people behavior. So when she speaks and then she looks, so what is this class going on now? This is the English class. This English Lord was asking for the add to my son that he go and take it to any class with his children. Then what the teacher is, A for apple, A for apple, A for apple, E for apple. Why this is always A for apple? Why A for apple? Apple is not to be taught. A is to be taught. So if they found that child should understand, oh, apple. And I repeatedly shown. All English. Books. These are simple. They are apples in a point. This is easily available. You can show it's more. That is why A apple तो हो जाते हैं कुछ तो पढ़ रहा है फिर थोड़ी दूर जाती है फिर उसको समझ नहीं आता फिर घूम के जाती है वहां खिड़की पे कोई दूसरी लगी है तो वो दूसरी खिड़की पे जाती है हिंदी की क्लास होती है फिर चाहते लाइक थोड़ा पानी यहाँ ये तब होता है जब बच्चा आपकी एज में पहुंचता है उससे पहले जो सबसे पहले हिंदी की क्लास होती है जब मतलब उसमें पीप करके देखते तब क्या हो रहा होता है तो वो देखिए
से कबूतर ये कबूतर
से कबूतर we have कबूतर की शो कबूतर देखो वही कबूतर but it's easy that's why all the कबूतर कबूतर क्या कहना बताने सीखता है वो कबूतर का यहाँ भी कुछ भी होगा कैसे कबूतर same way apple is a for apple A for apple so this transformation is also a little time taking but is the best way to teach it and that is why it is birds is kabutar then she is confident comes back and then she relaxes for some time then time is to go and pick the child back आज क्या पढ़ा आज क्या सीखा कल को जाना बिल्कुल भी नहीं कल क्यों जाना है कोई बच्चा स्कूल जाने के लिए कुछ ये नहीं कहता कि चलो चलते हैं there is something wrong that the child starts saying आज नहीं जाना कल चलेंगे there has to be something to be done kabutar enters into life at that stage because the kabutar and it goes and once again then it happens when the child is adolescent अब उसको कुछ चाहिए तो ना क्या होता है once again so this is not as if these teachers have played the role in expressing love communicating feelings why mediums have been chosen कितने गाने हमारे इंग्लिश देखिए देगा उसकी हीरोइन भी तो देखिए उसका सॉन्ग भी बहुत फेमस कौन सा सॉन्ग गाना अच्छा से there are many such that the pigeons have actually become the symbol of expression. But whenever there is love, there is always a war. होता है लड़ाई तो होनी ही और कोई नहीं तो इसे but this is not that it is so that they have expressed the feelings. There are many movies. रोशनारा देखिए इतनी पुरानी भी पिक्चर नहीं ऐसा तो ये जब कहता है ना so life begins at that and then it goes to the extent that मेरी चिट्ठी लेके जा कोई जरूरी है कोई जरूरी है कि आप कहें और कबूतर चला जाए और जहां कहें वहीं जाए देखिए जाना हो कहीं चला जाए कहीं आना हो कहीं आ जाए कोई पर चिट्ठी तो तब भी लिखता है चिट्ठी अब भी लिखता है डर तब भी लगता था डर अब भी लिखता है बात तब भी हुई थी तब भी वही तो बदला तो क्या बदला कबूतर that's what the change has you don't use anymore the pigeons what do you do now SMS WhatsApp write a mail and so on and so forth. So the pigeons have been replaced by that. It's a long path that it has come to this level. So I just show you the pigeons started playing as postmen. And so this was, as we have today, India Post, British Post, German Post, and so on and so forth. In fact, the pigeon post came the first. So that was the first post. So we show the slide show. So this I prepared a little while. The pigeon post. So you can see. So the pigeon post was used using the homing pigeons. What is a homing pigeon? Pigeons which are found in a home. That is why they are known as homing pigeons. They were very effective as messengers due to their natural homing ability. What is the homing ability? That you release the pigeon and in the evening it comes back. So कबूतर के पंजे से किसी की उम्र तोता से क्यों तोता is considered as fortune bringer. That is why people always saying the parrot always in the cage. You feed it well, even then when you open the door and it flies, never dies. अच्छा है महंगा भी नहीं तोता गाना महंगा नहीं एक बार ला उड़ा दोबारा ला उड़ा तो अभी तो शायद लौट के आए कोई तो शायद लौट के आए, but never, no one will ever return. But the pigeons always do that. So this is their natural ability, that they always come back to their home. So because of this, they were chosen over other animals. They are transported in cages to a destination. They were attached to messages and they are released. And they return back to the base with the message. So that's how they were used. और भी बहुत सारी खासियत है. They were used in great effect, not just carrying your letter, but in the military and the warfare, very effectively. Not ordinary wars, but the World War. So they were used in World War One. They were used in World War Two, and I'm not sure about what is going on now. But they have been used very, very effectively. How that was done and why that was done, that is also very important. So this is early history of this pigeon post that you can see. So this was about the Franco-Prussian War of 1871. 1871. Why? Man, so it's now more than one. So at that time, this was the only successful method and trusted method, time-honored method, that time delivered the method. Naturally, when there is one company, then it publicizes. मेरे कबूतर बड़े अच्छे हैं, बड़े ताकतवर हैं, सबसे पहले उड़ते हैं, सबसे पहले आते वापस भी आते हैं, दूसरी कंपनियां आती वो अपना अलग करती है. So these will be post medals, postage stamps, and so on and so forth will create it. Which one? मेरे पास तो बहुत कुछ. So that's how these were done. And this is, you can see the letter. So this was on Her Majesty's service. Majesty means the Queen of England and UK and the territories. This letter was sent using the pigeon post towards the place in France. Postage stamps, today you see on the postal stamps photos of different people. But when this pigeon post came, this was the food, like that. And you think that these were used only in 1870s and so on and so forth? Not really. I show you very recently also this has been observed and found, and that appeared in the newspaper also. I made a cutting of that and showing you now. So this was a pigeon carrying a letter that was found in Kanpur area on 16 February 2023 with a message. So this was the message that was recovered from the paw of the pigeon. Very recently, this type of thing has been observed that was appeared in the news. Time constant, I'm not sure you. So they are still in use. They are very, very beautiful creatures. There is a lot of history, there is a lot of literature about pigeons. If you read it, you will really love it. You will forget watching movies and all that. Bas kabutar ke gota hai. That's how things were. They were specially designed vehicles only for pigeons. वैसे भी देखो कितनी खास पहली तो वो वापस आए और दूसरी ये तुरंत जाएगा. You have a mobile? तो वो कितना पिकअप? In the first second, how much it was? 0 to? In the first second. 0 to? बोलो. 0 to? 50, 40. Kabutar takes almost 100. And the next second, it crosses 140. So it has a very fast pickup, like the metro. And the normal trains, they pick up. The metro train starts pick up immediately. The usual trains, they slowly start. So it has a very fast pickup. दूसरी बात ये है कि इसको कोई जो है ना दाना दिखा सकते हैं तो हवा में उड़ रहे हैं तो इसको बीच में से टपका नहीं सकते कहीं Third thing is, अच्छा about क्या? और बाइक का क्या? 1 लीटर में कितनी जाती? 70 किलोमीटर. वो 2-4 दाने में ही चला जाता है. And the range, आपका टैंक फुल भी होगा तो कितना कवर करेगा? एक रन में 600 किलोमीटर से ट्रैवर्स. And recently we had examples of birds flying the Atlantic and the Pacific. You can imagine the distance you can cover in one go when nothing is there to stop or to take rest or fueling in the air. Meaning, सस्ता, टिकाऊ और effective way और कुछ नहीं है. That is why pigeons were chosen in the military warfare as such. इतना ही नहीं. In the World War I, which was fought in Germany and the Allied forces, the whole course of war was changed just by pigeons. They trained like that. And after that, what happens is that, as you know, it was winter, and in that winter, the Russians started to drill, and the Germans pushing them into the interior parts of Russia, and they were lost their way. And the military or any soldier or human being survives on food. You need food, you need clothes, you need something. So this maintenance of the service depends on communication. Where is someone? So you have to know the location, you have to know what are the needs, demands, etc. But when there is no way to communicate, then what? They lost their way, they lost all communication equipment, etc. They were believed to have been lost forever. In literature, it is known as the lost theory of the American soldiers. How many they were in number? 194. कितने soldiers थे? And it was believed they were lost forever. So as the last hope of survival to attract, then they started releasing pigeons. They had some pigeons with them. So they released the pigeon, and then the Germans saw that so they shot it. Got suspicious, and they started shooting it. So one by one, they released. They had only 2 10 or 12 pigeons. All down. The last bird, the last pigeon, that was betrayed as the last hope. God is kind. So in the name of God, last pigeon also. And the same thing happened. It was also shot. Wounded very seriously. It lost one leg, it lost one wing, fell down, and something like miracle happened. The bird took the flight once again. And this time, reached the destination, delivered 12 messages, contact was made, they were saved, and just by one pigeon. And this pigeon, this sacrifice, because of this great service to the soldiers and army, was awarded the highest medal that can be awarded to any animal in the warfare is this. So this is cher ami. The French gave the name cher ami. In fact, cher means dear, ami means friend, dear friend. So that's what we call. So this is cher ami. Croix de guerre. Croix is from, is off, guerre is war. So this was the crown of the war. And croix de guerre with palm. Palm is gold in French. So the golden crown of the war was awarded to this. This is now in the French Museum. This sheriff. And it changed the entire course of the World War I because of one pigeon and because of one mathematician. Another day, I tell who he was. World War I was won by America and the Allies. But the Germans were not to sit down. एक लड़ाई होती नहीं, दूसरी शुरू होनी है. क्यों? क्योंकि हमें तसल्ली नहीं. कुछ कुछ हम कर सकते थे, कर नहीं पाए, अब की तो जरूर करेंगे. So World War II also started. So this was this World War One. World War II, they were very prepared. They knew the importance of the pigeons into the war. तो उन्होंने एक तो नहीं 2.5 लाख का इस्तेमाल किया. And this time again, they saved the life of 2,000 soldiers. And this time, 22 pigeons were awarded to the United States Army Pigeon Committee. So this is the map. For the gallantry, he also served. So this is the pigeon saying he also served in the army, military. So that is how World War One, World War Two, the famous world wars, the pigeons changed the entire course. There is a huge literature about the pigeons. Madam said 2 minutes. I'll take really 2 minutes. The count starts now. So this, there is huge literature. I can show you a lot more about the pigeons. So I just show you some of the pigeons. कितना सुंदर लिखा है कबूतर. देखा आपने? कबूतर देखा? मैं दिखाता हूँ कुछ कबूतर. So these are the kabutars from different places around the globe. So you can see Spanish kabutar, see, and then you see Arabian, German, Norwegian, American, Australian, Scottish, Russian, Canadian का तो कोई जवाब ही नहीं. English, Dutch, that means Holland, Netherlands, Austrian, Australian, Ireland, Turkey, French. देखो फ्रेंच कबूतर. अपने यहाँ भी बहुत है कबूतर. कैसे कैसे कबूतर. अंडमान game, Andaman wood, ashy hat, ashy wood, Asian emerald, barred cuckoo, Eurasian collared, green imperial, grey fronted, hill peach, laughing peach. हंसता है तो कितना अच्छा लगता है. कबूतर जब हंसता है तो कितना अच्छा. कभी उसे हंसा के देखो, अच्छा लगता है. Many such things. So you think that the pigeons were used only for that, but people are like that. Slowly things were changing. Slowly things were changing. Slowly things were changing. You were actually wishing कि कभी तो उनसे मिलना हो, कभी तो आपके सामने हो, कभी तो कोई बात हो. Things started changing, not just limited to the standing the bed. So this was the revolution taking place by thought. So then what was happening now? So this was the time of the inventions. तो क्या हुआ?
मेरे पिया ओ मेरे पिया पिया है कहाँ से कहती हूँ तुम्हारी याद सताती है.
हमारी याद सताती है. Good one, yeah.
याद सताती है, यादें याद लगाती है, मेरे पिया देखो, पिया मैं तुमसे कहती हूँ, तुम्हारी याद सताती है, तुम्हारी याद सताती है, पिया मैं बाग लगाती है।
हिंदुस्तान बहुत पछताए, बहुत पछताए, हम छोड़ के हिंदुस्तान बहुत पछताए, बहुत पछताए, कोई भूल तुमको साथ में लेकर आए, कोई भूल तुमको साथ में लेकर आए। आपको लगता है कि उसको लग रहा है कि कोई भूल हुई, साथ में लेकर आए, सारे किसी के साथ। अब ये नहीं पता चला, हमको नहीं पता, हमको नहीं पता कितनों के साथ भूल हुई, जो उनको साथ में लेकर आए, खुशी मना है कि अच्छा हुआ कि उनको साथ में लेकर आए। So things were starting change. So this revolution was of the telephone, lights off. So telephone was replacing all these people. And the early version of the telephone was, if at all you happen to see somewhere, telephone. So they were such big instruments. They were around 5 kg of weight. Receiver itself was 5. And the first telephones that you delivered were to the director and then at that phone. So when it came to the message label, still it was a very heavy. How they were talking. So when this bell will ring, quickly you be waiting for the bell to ring. You lift up the headphone and you keep at a distance of 6 inches away. Because the electromagnetic waves were so strong that it becomes closer to stuck to the ear. अब क्या होता है? इधर से इतनी जोर से बोलते हैं कि लगता है कि उसको सुनाई नहीं देता, और उधर वाला बिना बोलते भी इतनी जोर से उसको सुनाई देता है, सबको सुनाई। That is what is the purpose of telephone. सबको पता चले, मैंने तो फोन किया। So this was the charm of these telephones. Always when something is new, you always enjoy. You always admire. You feel pride in you that something special you have got. And soon then you want a better. And then the size is now reduced. It is no more tied to the wire. It is very small. You can hide in your palm. You can hide in the collar and so on. So things were changed. But what something did not change was our desire. Desire was to keep it secret. Communication is to be kept secret. So say that 8 minutes. So this desire to keep the secret with us is still there. And that is why this cryptography will live forever, because we just do not stay in the normal language of things. We change, and we change it in such a manner that is not understood by others. पहले तो यही इच्छा होती है कि मेरी चिट्ठी बड़ी और उसके बाद दूसरी होती पकड़ ली, चलो कोई बात समझ में ना आए, दूसरे की पहली दूसरी इसमें क्या लिखी? It starts with the school. And write small in the book, and you go to the library, oh, my book, where is my book? And exchange the books. It starts so coolly, so easily. But then there is somewhere in between the mom eavesdropper. She always looks into the pages. कॉपी में क्या है, बुक में क्या है, और चेक है, उसमें क्या लिखा है, किसको लिखा है, क्यों लिखा है. Eavesdropper are equally important. That is what it is. That unless these two are strong contenders, inventor as well as the destroyer, things will not progress. So to keep the secret, this lock has become symbol of law. It is the symbol of security. Locks are no more physically as such they are as they were. They only represent security. The thing is, madam, really good last 59 seconds. So things keep on changing. So I show you that in the modern times, when you use the Gmail or you use online bank system and so on and so forth, what do you see there? You will see something like this. So what do they use is this crypto system, which is known today as the RSA crypto system. And on the homepage, you will see the assets. What you will see and what you will not see. You will see what is written in black. This is written in hex. 58. Not 58. What is written in black is in hex to the base 16. What I have done is I have converted this into the normal base 10. The crypto system's strength is that it is difficult to factorize this number into non-trivial factors. And this, in 1976, the crypto system was invented. And then at that time also it was thought whether this system will sustain the thrust of the eavesdroppers or not. So they left into this. मैं दिखाता हूँ आपको चाची का डांस. किसका डांस? चाची का. Most famous dancer. चाची का. So this, as a testing, they do into the market or announce that decrypt this number. So this is one number, by the way, it's not a big number, you can check. And it was told that this is used, the RSA crypto system, to invent this number. And to find out basically the decrypted message amounts to factorization of this number. This is not a big number, you can count with this. Digits also. So one, first row, 4 rows, 432 is 128. This is bigger, 129 digits. It's not a big number. Big. So how much time do you think that one minute only? How much you will big time? Yes, yes, quickly. Huh? What, yeah. 8 seconds. कितना? 56 seconds. Yes, मोबाइल नो कैलकुलेटर नो लैपटॉप डेस्कटॉप का क्लियर कर दो. कितना लगेगा? 56 seconds to operate. Give a big hand to Shashi. Clap for her. So you will take 50 seconds. Anyone can just hurry on. What is that? अच्छा लगता है. So you will take 50 seconds to find the non-trivial factor for this number. Is it so? Say yes. Ah, good. Anyone who wants to do it faster than her? No, I'm बैठी नहीं खड़ी. Oh, अच्छा लगता है. So the same thing was about the Bell laboratories also. They also wanted to have an estimate that how much time it might take to factor this number into non-trivial factors, and open your ears. How much was the estimate? The estimate was zero. 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 कितनी zero? 16. मिलियन में कितनी होती? मिलियन में कितनी होती? 6. बिलियन में? 9. Times 3. ट्रिलियन में? 12. क्वाड्रिलियन में? 15. 40 quadrillion years was the estimate of the Bell laboratory. 50 seconds. We clap for you because we expect you will one day do that. So will anyone accept this challenge? Such a challenge? There was a prize also, $100. Naturally no one will. लेकिन दुनिया में सिर्फ हीरों की कमी नहीं होती. कहीं भी दो चार कुछ हो रहा हो, जाके कहते हैं अरे क्या हुआ, तो वो तो नहीं पता. फिर I'll solve your problem. What is the problem? कोई भी हो, I'll solve your problem. This is what is the zero knowledge protocol. So that was done actually. This was accepted, not by one. These were 4 people, Atkins, Graf, Lester, and Dillon, and they succeeded also in 1994. The estimate was 40 quadrillion years, not seconds or minutes or hours or days. These many years. And when did they succeed? This was 1994. Only 17 years this was truly attained with very little mathematics. And that is the beauty of mathematics. And your brain, that you will do it in 50 seconds, she will do in 10 seconds. So one day that will happen. And show lights off.
That's the B.I.G. Louis, Jim Summer, Baby Love, Jonathan, yeah, Super Baby Love, take it down. Still on one real time. It's the arms of my kids are words online.
And we will show it. Thank you very much. Do you have any questions? तुम क्या है, हम बातें करना पड़ता.
I would like to express my sincere gratitude to Professor R.K. Sharma for his insightful and engaging lecture. His talk provided valuable perspectives and deepened our understanding of the subject, reflecting his vast experience and expertise in the field. The clarity of presentation and the relevance of the ideas shared have truly enriched this session and stimulated meaningful thought among all of us. We are thankful for the time and effort he has taken to be with us and share his knowledge. It has been a privilege to have him with us today. Thank you once again, sir, for your valuable contribution. Professor Michael, are you here? Can you hear me?
Yes, I can hear you.
Okay. So I request Dr. Bijmohan, our session chair, to kindly introduce him. Yes, sir. Professor Michael, can you please switch on your camera? Okay, sir. You can also share your screen.
Sorry.
Hello, Professor Chapania. Here, Dr. Bijmohan. So let me introduce you a little bit to our audience. So Professor Michael Chapania is a professor and currently the head of the Department of Mathematics and Applied Mathematics at the University of Pretoria, South Africa. He holds BSc Honours in Mathematics from the University of Zimbabwe and MSc and PhD in Applied Mathematics from the University of Limerick, Republic of Ireland. Professor Chapania's research lies at the intersection of applied mathematics and real-world problems with significant contribution to mathematical biology and numerical methods for differential equations. His work includes modeling infectious diseases, ecological systems, and biological processes using advanced computational and analytical techniques. He is an accomplished researcher with numerous publications in leading international journals and has secured major research funding from organizations such as National Research Foundation, that is NRF, and Bill and Melinda Gates Foundation. He also holds an NRF C1 rating, reflecting his sustained research excellence and international recognition. In addition to his research, Professor Chapania is deeply committed to teaching and mentorship, having supervised several postgraduate and doctoral students. He has received awards for excellence in teaching and has played a key role in organizing international conferences and advancing mathematical sciences in Africa and beyond. So we welcome Professor Chapania to present his talk on existence and dynamics of traveling waves in crop vector-borne disease model. So Mike, over to you, sir, and welcome again. So we can just have a big round of applause to just welcome Professor Chapania. Thank you.
All right, thank you for a kind introduction. And I mean, thank you also for the invitation to participate in this international conference. Probably I should also put a special mention to Professor Ghosh. I've known him for almost 20 years now, and we've been in touch since the time she was at Simon Fraser University. But otherwise, thanks to everyone, thanks to the audience here. My talk today, I'm going to focus on vector-borne diseases, in particular, how they spread and how also we can control these diseases. I'm, of course, Michael Chapania from the University of Pretoria. That's where I'm currently based. All right, so just to get into the little details of my talk, I mean, everyone here has probably came across some aphids or some bugs, either on your small garden in the backyard. You might have a tomato plant, and you see aphids that are hanging around the leaves, or even the natural grasses. You can see there could be bugs that are there. Now, they are feeding on these plants, but at the same time, they potentially spread diseases. So as you can see in this picture, the way of spread can be different. It could be through the leaves, it could be through the stems of the plant. It can also be even through the soil itself. So, which means the spread of diseases in plants is actually more complicated if I can, for example, compare with human diseases. All right, so the work I'm going to talk about sort of covers a few colleagues and students of mine. And this is the short list of the collaborations that I've done. And you can see it goes France, Cameroon, Mozambique, we have South Africa. And in particular, the last name there is, she was an undergraduate student who also worked on one of these topics. So just to give a little bit of introduction into plant diseases. I mean, they've been known for years, decades, centuries. They go as back as 1200 BC in Egyptian writings. So this is not a new topic. It's a very old topic because plants, of course, crops are in particular important for our day-to-day lives. They are a source of food for all of us. One can probably pick a few of the notable disease outbreaks. For example, the Irish potato famine in 1845. Well, this comes to my mind because I did spend some time in Ireland. You also have the French wine industry around the 1878. You also have the CMD. So this is cassava mosaic disease that affects cassava plants. So this is around the Uganda and Kenya, which is a more recent outbreak. So one would see that crop diseases affect all of us. But one thing you will also find from the mathematical modeling literature is the fact that very few people are focused on crop diseases. You check the literature, there is a lot in terms of human diseases, but not crop diseases. Why is this important to study crop diseases? Of course, there is the food security part of it. But studying crop diseases also has its own difficulties, as you find many viruses affect crops. It's not only one virus, there are so many viruses. And you find the vectors that can transmit the same virus can be so many. So you can have whiteflies, leaf hoppers, stripes, and mealybugs. They transmit several other diseases. So if I can draw a parallel with the human diseases, you find.
Sir, your slides are not moving right now. So.
Oh, they're not moving.
No, sir. No, sir. It's on the first slide only.
Okay, so if I can you see it moving now?
So, slides are not visible, sir, right now.
Okay, so let me try to share. Apologies for that.
Try to move the slide. Yes, now it is moving. Now it's moving.
Okay, can I keep it like this or full screen? Because let's try the full screen. Let's see if you can see it.
See, slide number 2.
Slide number 2, plant insect interactions.
So you can see slide number 1 right now?
We can see slide number 2 right now.
Okay, if I move, is it moving?
It's still on 2.
Sorry. Apologies for that, because I'm not sure why it's not moving from my side. All right, probably let me just do this, share the full screen, but hopefully you should be able to to this.
Yeah, just try rolling right now. Yeah. Go
Yes,
third
it's-
slide, Mike, once. Yeah.
Yes, now it's moving, sir.
Now it's moving.
Now it's
Okay.
moving. Okay.
All right. So what I'll do is probably I'll just rush through the first few slides that I talked about. So the first slide after the title page was this one, and I was just trying to illustrate how different bugs, aphids, whiteflies, even worms do affect plants. And I did mention that this work is in collaboration with a few people, and these people include even students and across different continents. Then I did give a summary of how crop diseases have been documented in the literature, starting with the Egyptian writings and all the way to around 23 to 79 AD, and also some of the more recent but not so recent cases like the 1845 Irish potato famine, and probably a more recent of the cassava mosaic disease, which is around the 2015. I also mentioned that there are so many viruses that can affect crops, and the same can be said about the vectors. So vectors in this case, I'm talking about the whiteflies or the vectors that transmit the disease. There are so many, and each of the vector can transmit several other diseases. Then I did make a comparison with, for example, if you think of malaria, you know it's only the mosquito that can transmit malaria. But now for plants, you can talk of the cassava mosaic virus disease as an example, and you find several vectors they can transmit the same disease. So which means from the mathematical modeling point of view, it's not an easy case to actually present or study. So at the same time, we can use mathematical modeling. We can actually use that to understand the interaction of plants and the vectors, or even the control strategies that can be used. Of course, one of the traditional control strategy is just to an insecticide, you spray and then you kill all the vectors and so forth. But we all know that affects the quality of your product. It also affects the environment. So hence, the idea of mathematical modeling comes in. Now, another important thing is if one goes back to the title of my talk, I did talk of traveling waves. What does that mean in the crop context? We are talking about how the disease spread in a given area. So if you have your field, which is, let's say, maize, or it could be potatoes, now one is interested in how long does it take for the disease to start from one corner of the field to the other corner of the field. In some sense, how long does it take for the whole crop to be infected? And one can calculate the speed or the timeframes at which those things can happen. But of course, that depends on the kind of crops you have, the vectors that will transmit the crops, and other things that can be included in the modeling. Now, what are these other things that can be included in the modeling? The transmission of the disease itself. So in this case, I'm mentioning circulative virus or non-circulative virus. So circulative virus, it just means when the virus or the pest goes onto a plant, it feeds on a plant, then the virus gets into the gut of the aphid, and once it gets into the gut of the aphid, it stays there for the rest of its life. So that's the circulative virus. Non-circulative, it means it just stays on the mouthpiece, and then after some time, the virus disappears from the mouthpiece, which means the vector is susceptible again. So in that two classes, you can also have a non-persistent, semi-persistent, and persistent virus. to describe the two different cases. So non-circulating virus, they are also non-persistent, which means they disappear after some time, while it is persistent or persistent, they stay for the rest of the vector's life. Now, in plants, you can also talk about co-infection, which means a plant can be infected by two or more viruses. And if that happens, you have cases where it can be neutralism, which means the two virus or more viruses, they kind of stay together. They don't affect each other, so which means this plant is infected by 2, 3, 4 viruses and nothing, or symptoms don't go beyond the case where it's infected by one virus. Then you also have antagonism. In this case, it means one virus takes over and the other virus is suppressed, or synergism, where the two viruses, they actually push the symptoms of each other, and then the effects are more pronounced. So, I mean, some of these things are also observed in human diseases, where, for example, if someone is infected with HIV, and then you also get TB, then you might find one of the diseases actually overtakes more than the other disease. So one of the works that we did was on the sugarcane mosaic virus, which affects maize. And if the plant has the sugarcane mosaic virus and also has the maize chlorotic virus, if these two come together, you end up with what we call the maize chlorotic necrosis virus. And this MLN disease is more deadly compared to the other two. So in some sense, you have two viruses that cause another new virus to come up. And that new virus is more deadly compared to the previous two viruses. And this, again, in human or animal diseases, it's not yet documented. So I will sort of summarize a few, some of the few works that we have done. In this case, this was the cassava mosaic virus. So it affects cassava, and in particular, from that picture, people are interested in the tubers, those roots, because those are the ones that they need for food. And once the plant is affected by the cassava mosaic virus, these tubers, they tend to disappear, or you don't have much of that. So which means it's affecting the production. So just to show, this is from 2023. So the darker areas, that's where the people grow cassava more than other people. So from the map there, of course, I can tell, I don't know if you can see my mouse, but I'm somewhere here, that's in the south tip of Africa. And here we don't grow cassava that much. You'll find there's few small-scale farmers that will do that, but there is no data in terms of the production of cassava. But in the darker areas, South America, Central Africa, and Asia, they do grow cassava quite a lot. So the cassava mosaic disease is the one that affects the cassava a lot, and of course affects the production. And the virus that carries this virus, that's the bee tuberculosis virus. And what it does is it causes the leaves. Well, the symptoms that one can see is that the leaves, they start to be yellow. And at the same time, they start to fold. And at times, the plant itself can die. But the interesting part of this is the beta-bacteria, the vector that transmits this disease, it's attracted to these yellowish leaves. So it actually, when the plant is yellow like this, the aphids actually are attracted to this, and that actually pushes the spread of the disease. So in terms of the modeling, we follow kind of similar to human disease, where we do compartments. So in this case, I can say On the left, which is the circles, these are the crop compartments. And on the right with the boxes, those are the vector compartments. I mean, it's a more simplified model where you just look at the infected crop and the healthy crop. And you also look at the susceptible crop and the susceptible vector and infected vector. But what I want to highlight in this, which is sort of different from human diseases, is the fact that the way the disease multiplies in the vector or in the crop, it's kind of different from human diseases. So I just want to check, can you still see my screen?
No, sir. No, sir. It's not visible. You have to share it again.
I'm not sure then what happens.
Yes, now it's visible. Now the screen is visible.
All right. Okay. Thank you. All right. So I was talking about this. So after discussing the different modeling or the different properties of the disease or how it affects the crop, I said now we talk about the modeling part where we do these compartments. But what's more important here, or what I want us to take out of this, is the fact that the health plant, of course, after the aphid feeds on it, it can move from the healthy to the infected. And once it's infected, a farmer may decide, okay, this yellowing of leaves on this plant, I'm going to pull it out. So that's the gamma that we have there. So a farmer can decide to just pull out the plants and destroy them. Secondly, the biomass production, which means the way the plant itself multiply or grow, it's affected by the virus itself, or by the vector. And at the same time, the vector itself also is affected by the infected plants. Like I said, when the yellow leaves come, the vector itself is attracted to the plant, so that sort of increase the spread of the disease. Now you also have the KP. Now KP is just the harvesting, so the farmer here and there pulls out the plants and harvests the tubers. So that's sort of a rough sketch of the cassava mosaic virus. Now, I just want to discuss again another sub modeling project that we did, and in this case, this is for the grapevine leaf roll associated virus, and it affects the grapevines. In this case, you see, let's start on the picture on the right. This is supposed to be green, but when the virus attacks, then it starts to be reddish, and of course, the growth is affected, and also it affects the harvest. Now, on the left, you see that reddish part is actually the virus that is affected that part of the field, and one can think of a wave that's coming from the top corner there. It looks like that's where it started, and then it's affecting the whole crop, moving outside the screen or towards the screen. So that's the grapevine leaf roll disease. So if one looks closely, you can see the different effects that it has on the leaves. But what transmits the disease is Planococcus ficus, and this is what is illustrated at the bottom of the picture. Now, these aphids, as you can see, they have different sizes. They also feed, or at times they don't feed. So just to give a rough picture of what happens is, they have three different instars. So the first instar is when they are tiny, which means the wind can blow them around, and they feed when they are at the first instar. So that's where the transmission of the disease is more significant. Now they grow to the second instar where they're a little bit bigger, they don't move that much, and going to the third instar where they are much, much bigger and they feed less. Now they also go into their adult stages, and in the adult stages, they don't feed. Which means in this case, it's important that we understand the different stages in the life cycle of the planococcus figures, because that actually tells us how the disease will be spread. Now, if one looks at a compartmental model of such a case, then you have the first instar, which is the subscript 1, second instar with subscript 2, third instar with subscript 3. Now you see in this case we removed the adult stage because it doesn't fit. Then on the far right side, which is the blue, that's the plant itself. So you can see the modeling here is quite different from the previous one. So this I just wanted to just illustrate how understanding the few or the small dynamics, the biological dynamics of the disease is important in terms of how one would model the particular disease. So now what I want to probably discuss until the end of the rest of the talk is this particular model. Now, this is a generalized model. I'm not referring to any particular disease, but it's applicable, of course, to majority of cases of plant diseases. One can think of someone who is planting their tomatoes. You plant it once, and you try to take care of the plants until you harvest. So there is no replanting. The same way can be said, let's say you have a maize field, you plant at the beginning, you take care of your plants, either spraying with the insecticide or pulling out all infected plants. But the idea is at the end of the season, you want to harvest. So this is kind of the model that I have here. So the top part, that represents the plant population. So you can think of HP as the number of healthy plants that you have in your particular setup. They get infected by the vector. So the bottom two compartments is the susceptible vector, the infected vector. So once they are infected, they move to the latent case. So latent, it just means they are infected, but the disease is not affected the crop yet. But once it takes a little bit of time, it moves into the infected class, which means if an aphid feeds on the infected, it also gets infected. Then you have the last class, which is the recovered. All right, or you can think of those plants that are dying and removed from the system. So at the bottom there on the susceptible vector, you have the susceptible vector which can feed on infected plant and gets infected and moves into IV, which is the infected vector. But this infected vector, it's a non-circulating virus, which means it's just on the mouthpiece of this vector, and after some time it recovers, which means it's no longer infectious. And you wait until the next feeding cycle, then it gets infected and the cycle goes on. So what I want to highlight in this case is a few parameters. Delta, which is the recovery rate. So we're just saying once infected the vector, after some time, probably it could be a day, then the virus disappears from the vector, and until the next feeding cycle, it gets infected. So that actually separates the persistent when delta is 0 or non-persistent virus when delta is positive. I also want to highlight the gamma, which is the sanitary harvest. So the farmer here, once they see that this plant is infected, they just remove it from the field. Another important parameter in this case is the contact rate. So the contact rate between plants and the vector. I think some of us probably have seen in some, especially the citrus farmers, they cover the plant to actually protect it from pests, and that's where the conduct rate comes in. Or even in some cases for small scale farmers, they can do what we call intercropping, where you can have tomatoes and, let's say, maize in the same field. So the idea there is just to reduce the rate at which the aphids, they move between, let's say, a plant to plant or tomato to tomato. So the maize there is sort of a way to block or to reduce that movement. So that's the conduct rate that I have in the model. So in terms of the model or the equations themselves, I'll just quickly summarize this. So we use a deterministic model and we separate the plants and the vector population. If I can start with the plant population, you have your healthy plants. They reduce because they are being affected by the virus. And they move into the latent class. And from the latent class, they move into the infected class. And from the infected class, they can actually be removed or recovered. So once recovered, by the way, in this case, they are not infected by the virus again. Then you move on to the vector population. As I'll show you a little bit later, the vector population, total vector population, we assume it grows logistically. And it can be seen on the first equation, it's just a sort of a logistic growth. And then you have the once it's infected, it moves also to the infected class IV. But at the same time, you have this exponential function here, which is multiplied by delta. Remember, the delta is just telling us the rate at which an infected vector actually goes back to susceptible again. And in this case, we just use an exponential function, which is the rate at which the virus slowly disappears from the mouthpiece of the vector. All right, this is just scaling. That's a mathematical step. But what I want to highlight in this case, so the small letters, they still represent the same compartments: healthy plants, HP, latent plant, LP, infected plant, IP, infected vector, IV. But you also have K, which is the total plant population. So if a farmer plants their plants at the beginning, that's the total plant population. But as the effects of the disease goes in, K will reduce, of course. Now, V, which is capital V, that's the total vector population. As I said, it actually grows logistically, as you can see. So you can see now in this case that the total vector population is not affected by the plant. So the equation for B, you don't have any effects of the plant population. So this is sort of the usual mathematical discussions one can do where you calculate what we call the basic reproduction ratio, which actually explains the rate at which the plants or one infected vector affects the plants. So important parameters there, which I highlighted at the beginning, is the delta. So as delta goes to 0, your R0 goes up, so which means the disease might be difficult to control. You also have the phi, which appears in the numerator there. That's the conduct between the vector and the plant. And you can see for you to actually reduce the disease, you have to reduce phi. And which means reduce the access of the vector to the plant, right, or the conducts. So some of the simulations that one can do is just to check if I start with a particular number of plants, and in this case, we're saying it's a non-persistent setup, and plants or all plants are initially infected. Now, what I want to see is at the end of the season, harvesting period, how much of the plant do I get? And in this case, under two setups, the first setup is without sanitary harvest, which means you are not actually removing infected plants. And in the second picture, you are actually doing sanitary harvest, which means you are removing infected plants. So if you don't remove any infected plants, the picture on the left says you might harvest about 65% of your plants. Now, put sanitary harvest, you can increase actually your production to about 80%. So this is just to illustrate the effects of the sanitary harvest on the total plant harvest. So we can actually do different setups now, in this case where the infection is introduced from the vector. So you're saying initially it is the vector that has the virus and the plant is all susceptible. You can also do similar calculations, and again, it's just because of the numbers, it's coincidence here, that without sanitary harvest, you are about 65%, and with sanitary harvest, it's almost 80%. So you can also do different or check different dynamics to see how the effects of the sanitary harvest, conduct, and so forth affects your total harvest. So on the right picture, I should highlight that in this case, we also put what we call barrier plants, which means you reduce the conduct. And you can see the production can be increased up to almost 100%. While it's without that, or with a higher conduct, it's about 80%. Now, the second part of this model is just to say, okay, in practice, we know plants don't move, but vectors, they do move. If you recall the model which I discussed right at the beginning, the one where we have the grapevine leaf frost disease, the vectors themselves can be blown by wind, but at times vectors can also fly. And which means one would want to be a little bit realistic around that model. The crop itself does not move, so the crop set of equations, they remain the same, but the vector population, we included this diffusion, which is kind of just the random movement of the vector. So we're going to discuss this in one dimension, but of course, one can extend this to more than one dimension. That could be also an interesting picture to look at. Now, this model in this setup allows us to then calculate the spread of the disease. That's the interesting part of this model setup. Now, one of the things that I should highlight here, if you look at the second set of equations, this vector population model, if you add these equations, you notice that the conduct terms here, they cancel out. The exponential terms, they also cancel out. And what remains is actually the traditional Fisher's equation. So that's what you have. And what we know about this equation is, I think it's a most well-studied equation in terms of the traveling waves. And we can actually calculate the traveling wave speed. Now, the question that we have in this case is, okay, so the total vector population actually gives a traveling wave, and we can calculate the speed at which the total vector population travels. But this does not actually give us a picture at which the disease spread, because we don't know how the infected vector spread. So that's actually the question one cannot answer from this by just summing the two equations. So what we did in this case, we had to then go into what I would call submodels. So submodels in the sense that in this case, I assume all plants are infected. So which means K, which was the total plants, is exactly our IP. That reduces your system of equations to just two equations, as you can see there. The second equation, that's the usual Fisher's equation, all right? But the first equation, it is a little bit more complicated equation, but again, it's a reaction diffusion equation, which we can write in a vectorized form as given below there. All right. Now, the interesting part of this is this actually appears to be a monotone dynamical system. So if it's a monotone dynamical system, then we know the tools, or we have the tools to start them. But if you go back to the original model, it's not a monotone dynamical system. So studying traveling waves from the original model, it's a little bit complicated. But we can actually still extract quite a bit of information from this submodel. So some of the results that one can actually extract in this case is that this reduced system, it admits a monostable traveling wave solution with a single spreading speed CV, and one can actually see that's the same traveling wave as the Fisher's equation. So one would also see that well, delta is not part of this speed, and also the conduct rate phi is not part of that traveling wave speed. And well, it is a result that one can, of course, prove using the fact that it's a cooperative system, and monostable, you have 0 as one of the equilibria and 1 as one of the equilibria. But I will spare the details, but the proof is actually a straightforward analysis of this system, which happened to be a cooperative system. Now, one can also look into a subcase, and in this case where we're saying the vectors are already established in the crop, which means we have our V equal to V star, so the whole crop is infected. Again, with a little bit of simplification, then you end up with a system of two equations as given in this case. So it's again a very nice submodel. You can see that logistic setup is lost, but again, it happened that this submodel is also a monotone dynamical system, and you can use the same tools for monotone dynamical system to prove that there is a traveling wave. So what does it mean? It just means for particular cases, one can actually tell how fast does the disease spread in your field. So we didn't test this for particular numbers. These were just for random numbers. And as an early warning, one can give to a farmer to say, if you have to use this pesticide, you better do it immediately, or if you delay, then the whole crop is infected and the loss will be big. So that's the discussion I have on the monotone dynamical system, how that can be used to actually find the wave speed. So I'll give the conclusions that for plants, while it's difficult because there is so much happening in plants, there are so many aphids that can carry the same disease, and also several diseases can be also carried by one aphid. So it makes it very difficult, but under some simplifying assumptions and so forth, one can actually try and understand how diseases or plant diseases are transmitted. Of course, here we use the theory of monotone dynamical systems to show the existence of traveling waves. One can also use other tools, but this is a well-established theory which made it very easy for us to do the analysis. Now, there are things that one can also go into, things like discuss further what we did, the virus lifespan. That was the delta that we discussed, to say if the disease disappears from the mouthpiece quite fast, you can actually reduce on the effects of the virus itself, or you can also slower, in this case, the infection front, which means the spread of the disease. So there are some ongoing work that we are doing here. In particular, the cases where you go over different seasons, because if you look at one season, it doesn't mean at the end of the season the disease disappears. It's still there. When you replant, the effects of the disease from the previous season can also be carried over, especially for viruses that come through the soil or the bugs in the soil. So this is the end of my talk, and thank you so much for listening.
Thank you so much, Professor, for such an insightful talk. The way you described the application of mathematical modeling to real world challenges in agriculture and disease dynamics was really fascinating. I would now like to request Professor Sudeshna Ghosh to kindly give the vote of thanks.
Good morning, Professor. Can you hear me?
I can hear you.
Hi. So I thought of penning down couple of things for you because it's a long association of you with mine. So I thought of penning it down so that I don't miss any important point. Okay, so I will be reading out that. Okay. So first of all, good morning and sorry for the delay. I know it's almost 9:30 your time to go for the office. Sorry for that. Okay.
No, that's fine.
Yeah, yeah. So we truly appreciate your effort and time. And sir, what I have understood from your talk, it was on traveling waves in crop vector borne disease models, and it was very interesting indeed and easy to understand the way you explained. Thank you so much. So you clearly explained how these diseases spread through vectors like insects and why it is important to study their spatial behavior. The examples you shared, such as maize and cassava diseases, made the discussion very relatable. I also found your explanation of traveling wave solutions and how different parameters affect the wave speed very insightful. It gives us a good understanding of how mathematical modeling can actually help in monitoring and controlling such diseases in practice. Now, on a personal note, this is what I thought of telling in on records. I would like to share that I still remember when I was doing my PhD, you were a postdoc at Simon Fraser University, and you were the first person who taught me about MATLAB, LaTeX, and how to make presentation. And you won't believe nowadays I am teaching LaTeX to others. So it's thank you so much, Mike, for that. Okay, you have played an important role in shaping my research. From you, I learned how to approach research in a structured and organized way. Thanks, Professor, once again for your time and your talk. We really appreciate you. Thank you so much, sir.
Thank you so much. Thank you.
Thank you, sir. You can leave now
All
if
right.
you want.
Thank you. All right. Thank you. Bye.
So, on behalf of Department of Mathematics and my personal behalf, and Amity School of Applied Sciences for sure, I extend my heartfelt gratitude to all the speakers. Professor Sharma, let's give a big round of applause for him. Professor Mitra, Dr. Vishnu Mohan, please, sir. And Professor Nitra and Professor Chopania, sorry. So, for their insightful and enriching presentations throughout this technical session, each talk has contributed significantly to broadening our understanding and has highlighted the depth and diversity of research in mathematical sciences. I would especially like to thank our session chair, Professor Dr. Brij Mohan, for his excellent coordination and for guiding the session so smoothly. Thank you so much, sir. And we are honored to have us with Professor U.C. Gupta. Sir is an eminent professor, sir, from IIT Kharagpur, from where I did my MTech. So I was sharing many of our memories. Thank you so much, sir. Yeah, thank you. My appreciation also goes to the participants for their active involvement. Last but not the least, I will like to acknowledge the organizing committee of this mathematical track. Dr. Sarika Jain, please, a big round of applause. Dr. Kamal Kumar, Dr. Kamal Kumar, Dr. Rita Bharadwaj, Dr. Ayushi Chakra, and Dr. Gagan has gone somewhere. So, a big round of applause to all of them. Thank you. So, now I will request Dr. Chakra to. So, and also the audience. Thank you so much. A big round of applause. All the faculty members, please come to I will make it. एक बार आओ आप लोग कल लोग के साथ फोटो खिंचवाओ प्लीज कम हम चल दो वही लोग कमल सर एक बार आप ये साथ खड़ा हो सर बच्चे आओ सर लोग के साथ सर 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 यार सर आप लोग सर आप सब आ जाओ नहीं ठीक है बच्चों के साथ आप इधर आ जाओ कौन किस पे इधर आओ पीछे को खड़ो 50 seconds में आओ इधर आओ और बात आई इधर आओ जल्दी cheers नहीं आप सबके साथ इधर वो होगा नहीं Thank you. सर आपने बैग क्यों नहीं? सर आपने सर भी आ रहे हैं दोनों आ रहे हैं Thank you.
वो स्क्रीन मैंने क्लिक करी, ये मैंने क्लिक करा।
हाँ 2:30 पे कल मेरी पोडियम पे हुई नहीं ना यहाँ पे थोड़ी वो देती हूँ ना रैंडम कि मैं बोल रही हूँ एक्टिंग भी नहीं मारी जाती बस ठीक है थैंक यू सो मच
आ जाओ आ जाओ
एक दिन तो हम लोग भी थोड़े से मैं पीछे बैकग्राउंड ठीक करूं? आयुषी दिखा रहा है ना, रुको ऐसे खींच देती हूँ इधर से। थैंक यू मैम। थैंक यू मैम। मैम अब हम लंच के बाद फ्री है ना, यही सब प्लेनरी सेशन है, उसके बाद
वैलिडिक्टरी है,
फ्री होगा वहाँ पे डी ब्लॉक वाले
डी ब्लॉक है। हाँ, लंच करके वहीं जाना है, सब वहीं जा रहे हैं। वंदना, एक वंदना